A student comes to school by a cycle whose tire is filled with air at a pressure 240 kilopascal at 27 degrees centigrade. She travels 8 kilometers to reach the school, and the temperature of the bicycle tire increases to 39 degrees centigrade. What is the change in pressure in the tire when the student reaches the school? The pressure is 240. There are two pressures. So P1 is equal to 240 kilopascal at, that is T1 is equal to 27 degree centigrade. She travels 8 kilometer. So the distance traveled is 8 kilometer to reach the school, and the temperature of the bicycle tire increases. So now T2 is equal to 39 degree centigrade. What is the change in pressure? So what is the change in pressure? Delta P is asked. Change in pressure is asked when the student reaches the school. So change in pressure is nothing but, that is final change minus, that is final pressure minus initial pressure. So we have these parameters. Now we can apply the equation here, that is equation of ideal gas, equation of state for ideal gas. We know equation of state of ideal gas is given by PV is equal to NKT. Now we have two conditions here. We know P is equal to pressure, V volume, N Avogadro's number, K Boltzmann's constant, and T the temperature. So condition 1, for condition 1, that is in the initial state. So case 1, where we can apply the formula P1 V1 is equal to N is Avogadro's number constant, K Boltzmann constant, and T1. Now what is the case 2? About to reach the school, where the pressure is P2 and volume is V2, and N and K are constant, and the temperature becomes T2. Right? Now there is no change in volume because volume remains constant. So V1 is equal to V2 is equal to V. Now let us consider this as equation 1 and this is equation 2. P1 V, because V1 is equal to V. Let us divide equation, that is 2 by 1. So in that case P2, V2 is V only, divided by P1 again V is equal to, here NK T2 by NK T1. So these two can be cancelled. Now P2 by P1 is equal to T2 by T1. So we want P2. So in that case, P1 into T2 by T1. So this is a formula to be applied. And here it is given as kilopascal. So the other pressure will also be in kilopascal. And then temperature is 27. We can convert this into Kelvin. So you can add 273. That is T1 is equal to 27 degrees Celsius. It means you can add 273 to get Kelvin. So 10, and this is 300. So T1 is equal to 300 Kelvin, and T2 is equal to 273 plus 39 degree to give the Kelvin value. So 3 plus 9, 12, balance 1, 4, 11, and 3 Kelvin, 312 Kelvin. This is the T2 value. So we have T1 value and T2 value. Now we can suitably substitute here. Okay. And this Pascal is nothing but kilopascal can be converted into, that is 240 into 10 cube Pascal. Now we have got all these values, substitute and get the answer. So P2 is equal to, what is P1? 240 into 10 cube. And T2 is 312 Kelvin divided by 300. Now we get, let us work out. $240 into 240 into 312 divided by 300 is equal to 5990. Let me check once again. 240 into 312 divided by 300. That gives 249.6 into 10 cube Pascal. So the pressure is 249 the pressure of the tire. So we can write the answer like this. The pressure of the tire when the student reaches the school, that is P2 is equal to 249.6 into 10 cube Pascal, or it can be called kilopascal. Okay, so this is the answer.